Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of two questions that have appeared in the JEE Main examination held in the January 2025 session. These two questions are from the section Sets, Relations and Functions. And these are the questions related to sets and relations. The questions are designated as question number 7 and 8. Right. This is the question that appeared in 23rd January 2025 in the second shift, and it is related to relations. Let capital X is equal to R cross R, where R is the set of real numbers. Define a relation R, capital R, on X as the ordered pair A1, B1 related to by the relation R to A2, B2 if and only if their second components are equal. That is, if and only if B1 is equal to B2. We are given two statements. Statement 1, R is an equivalence relation. Statement 2, for some A, B belongs to X, that means for some given A, B belongs to X, the set S is equal to the set of all ordered pairs X, Y from capital X such that X, Y related to the A, B represents a line parallel to Y is equal to X. In the light of the above statements, choose the correct answer from the options given below. We are given four options. Option 1, statement 1 is true and statement 2 is false. Option 2, statement 1 is false but statement 2 is true. Option 3, both statements 1 and statement 2 are false and both are true. Right. Let's now discuss the solution of the problem in detail. We have X is R cross R, the Cartesian product of R with R. So the set of all ordered pairs coming from X, Y, coming from X belongs to R, Y belongs to R. That is capital X, where capital R is the set of real numbers. And it is given a relation R on X defined as A1, B1 related to A2, B2 if and only if their second components, that is B1 is equal to B2. Right. We are now checking the properties of this relation R. Is it reflexive? For that, consider first, for each A1, B1 belongs to X, we have A1, B1 related to itself because their second components are equal. B1 is equal to B1. Thus, A1, B1 related to A1, B1 for all A1, B1 belongs to X. Thus, the relation R is reflexive. Let's see its symmetry. Is it symmetric? A1, B1 related to A2, B2 implies their second components B1 is equal to B2. B1 is equal to B2 implies B2 is equal to B1. Therefore, A2, B2 related to A1, B1. So, whenever A1, B1 related to A2, B2, we have A2, B2 related to A1, B1. Thus, the relation R is symmetric. Go for the transitivity. So A1, B1 related to A2, B2 and A2 comma B2 related to A3 comma B3 implies from the first B1 is equal to B2. From the second, you will get B2 is equal to B3. This implies B1 is equal to B3. That means the first ordered pair A1 comma B1 related to A3 comma B3 because B1 is equal to B3. We are using the both ways of this if and only if. Both ways of this if and only if. This implies the relation R is transitive. Thus, the relation R is reflexive, symmetric and transitive. Therefore, R is an equivalence relation. Agreed. Therefore, the statement 1 is true. Right. We move to the next slide for the discussion of statement 2. Right. Statement 1 is true. And the statement 2 says, for some A comma B ordered pair belongs to X, the set S consisting of all ordered pairs X comma Y belongs to X, satisfying X comma Y related to A comma B represents a line parallel to Y is equal to X. Is it so? Now let us discuss that. Now given for some A comma B ordered pair belongs to X, we have the set S is equal to the set of all ordered pairs X comma Y belongs to capital X, satisfying X comma Y related to A comma B. Now use the definition. The set of all ordered pairs X comma Y belongs to X. X comma Y related to A comma B means the second components must be equal, Y is equal to B. That is the set of all ordered pairs X comma Y such that X belongs to R, Y is equal to B. It is a set of the ordered pairs X comma B, Y is B, where X belongs to R. So what are these? What are these X comma B? X belongs to R. As X is varying, B remains the same. What is this? It is a line. It's a line parallel to x-axis given by the equation y is equal to b. So it represents a line y is equal to b parallel to x-axis. But in statement 2 it is given it is parallel to y is equal to x. Therefore, statement 2 is not true. So, thus what we have shown, statement 1 is true and statement 2 is not true. Let's look at our options. And our answer tallies with option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. This problem is pretty easy one. We move to the next slide for the next question. This is the 8th question. This question has appeared on 23rd January 2025 in the second shift. It is related to the concepts of sets. The given question is, let A is equal to the set of all ordered pairs x comma y belongs to R cross R, satisfying mod of x plus y greater than or equal to 3, and B is the set of all ordered pairs x comma y belongs to R cross R, satisfying mod x plus mod y less than or equal to 3. If C is the set of those ordered pairs x comma y belonging to A intersection B, satisfying x is equal to 0 or y is equal to 0. Right. And then sigma of mod of x plus y, where the ordered pairs x comma y belongs to C. That means sigma mod of x plus y, where this sigma summation runs on those ordered pairs x comma y belongs to C is, we are given 4 options. And if you want to answer this question without using the geometry, it will be very extremely difficult. But whereas if you use the geometric ideas, that is what are these and all that, geometrically seeing, it becomes easier. So I will go in that approach. Right. Solution. First we consider, we have B, set B. Set B is the set of all ordered pairs x comma y belongs to R cross R, mod x plus mod y less than or equal to 3. And this mod x plus mod y less than or equal to 3 is to be broken. You break this into 4 situations where x is positive, both x and y are positive, x positive, y negative, x negative, y positive, and both x and y negative. These are the 4 possibilities you can consider. So option, we take the first possibility. X positive, y positive. Consider the line equality, x plus y is equal to 3. Let's call it as L1. What is this one? It is a straight line through 0, 3 and 3, 0. So these are the points of intersection of this line with the coordinate axis. Right. So this is the two-dimensional plane and this is the line L1. Right? Passing through 0, 3, 3, 0. But we have to consider this inequality. Now x plus y less than or equal to 3 consists of all points on L1, y on because equal to, and below the line L1 because it is less than. Is it below or above? How do we decide? So what you do is you take a convenient point. The most convenient point for us is 0, 0. Substitute in this. 0 plus 0, that is 0 less than or equal to 3. It is satisfied. Therefore, it represents the region in which this 0, 0 is present. That means in this, below the line L1, all this, right. Go to x positive, x negative, y positive. Then L2 will be minus x plus y is equal to 3. What is it? It is a line through 0, 3 and minus 3, 0. Right. So this is the line. And we have to consider the inequality. So minus x plus y less than or equal to 3 consists of all points on L2, yes, because it is included, is equal to is included, and below the line L2. Why below? Take the convenient point 0, 0. Substitute in this. It is satisfied. Therefore, this represents that region in which 0, 0 is present. So, it is the below. Right. Go to the third case. Now, x positive, y negative. So, L3 is x minus y is equal to 3. What is it? It is a line through 0, minus 3 and 3, 0. Now consider inequality. So this is the line. And 0, minus 3 is here, 3, 0 is here. Consider the inequality. X minus y is less than or equal to 0. Consists of all points on L3, on the line, above the line L3. Again, 0, 0. Substitute in this. It is satisfied in this inequality. So, it represents that region in which 0, 0 is present. That is above the line L3. Similarly, fourth case, x is negative, y is negative, L4 is minus x minus y is equal to 3. It is a line through 0, minus 3 and minus 3, 0. So, this is the line. So, these are the points. Right. And consider the inequality. Minus x minus y is less than or equal to 3 consists of all points on L4 and above the line L4. Agreed. Now, this is the union of all these things. The union of all these and, not union, I am sorry. And. So and means intersection. So therefore, what is B? B is the set of all points that lie inside and on the square with vertices 3, 0, 0, 3, minus 3, 0, and 0, minus 3. How do you get this? This is by taking the intersection of all those 4 regions. So this is the set of all points that lie inside and on the square. On because equalities are there, inequalities are there. So it's the square with vertices at 3, 0, 0, 3, minus 3, 0, and 0, minus 3. Right. So the B, capital B we got, and we have to go to capital A and take its intersection. Right. Right. So we have B, and what is B also? We have represented B here, and B is the set of all points that lie inside and on the square with vertices, this as shown here. We have A, the set of all ordered pairs belongs to R cross R such that mod of x plus y greater than or equal to 3. We consider 2 cases where x plus y is positive, where x plus y is negative. So that we will write it as A1 union A2. Right. So for the x plus y positive A1, x plus y is negative A2. So where A1 is set of all ordered pairs x comma y belongs to R cross R such that x plus y greater than or equal to 3, where x plus y is positive. So what is this? What is this? At one stretch I will talk about this. I'll talk about this one. So A1 represents what? A1 represents the set of all points that lie on this line, x plus y is equal to 3, and above, all points that lie above this line. So A1 consists of all points on L1, x plus y is equal to 3, and above the line L1. Why this above the line? Why this above the line? Now take your convenient point 0, 0, substitute in this. 0 greater than or equal to 3 doesn't satisfy. Therefore, the region, this region A1, is that region in which 0, 0 is not present. That means it is the line and above it. So right, what is A2? A2 is set of all those ordered pairs x comma y belongs to R cross R minus x minus y greater than or equal to 3. It is the situation when x plus y is negative. Right. So what is this? A2 consists of all points on L4. This is the L4 minus x minus y is equal to 3, and below the line L4. So this is the below the line. Now first of all, you take A1 and intersect with B. So B is this one. A1, all points are on this line and above. If you take the intersection of A1 with B, it is this line segment joining 0, 3 to 3, 0. And you take A2, A2 is this region, intersect with B, then you get the line segment joining minus 3, 0 to 0, minus 3. Now we consider A intersection B. A is A1 union A2 intersection B. Use the distributive law A1 intersection B union A2 intersection B. And what is A1? All points on this line and the points above the line, intersection with B. It is the line segment joining 0, 3 to 3, 0. That is the set of all ordered pairs x, y, where y is equal to 3 minus x, where x varies from 0 to 3. This is A1 intersection B. Right. What is A2 intersection B? A2 is this region, those points lying on this line, and the below this line intersection with B is this line segment joining minus 3, 0 to 0, minus 3. That is the set of all ordered pairs x, y is equal to minus 3, y is equal to minus 3 minus x, where x varies from minus 3 to 0, including minus 3 and 0. So, now given C is the set of all those ordered pairs x, y belongs to A intersection B, such that x is equal to 0, y is equal to 0. So, on this line segment, you have to consider those ordered pairs for which either x is 0 or y is 0. What are those ordered pairs? For x is equal to 0 or y is equal to 0, 0, 3 or 3, 0. And what are those ordered pairs on this for which x is 0 or y is equal to 0? They are minus 3, 0, 0, minus 3. So, C consists of only these 4 points. And C is the set of all those ordered pairs 0, 3, minus 3, 0, 0, minus 3, 0. So now you have to find sigma mod of x plus y, where the sigma runs on those ordered pairs x, y which belong to C. That is mod of 0 plus 3 plus mod of 3 plus 0 plus mod of 0 plus minus 3 plus mod of minus 3 plus 0. That is 3 plus 3 plus 3 plus 3 4 times, that is 12. Let's look at our options. Our answer 12 appears against option 2. Therefore, the answer to this question is option 2. Right. That is the detailed discussion of this question. As I have already mentioned you in the beginning of the question, this question is to be seen geometrically. Then it becomes easier. Otherwise, it will be difficult. Right. I am sure that you have understood the solutions of these 2 problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we will certainly meet again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.